Whenever you see a film or a TV show set in the future, or for that matter, set in the past, the establishing scene that lets you know what era you're in, the first cues you get that tell you, are transportation, right? And I don't think it's an accident that our concept of where we are, our understanding of modernity is wrapped up in how we move people and how we move things. And the pace of change has been extraordinary. It certainly was extraordinary in the 20th century. I would actually argue in terms of things that are visible and physical, it may have slowed a little bit, but is about to accelerate in a big way. And I say this not just to have us marveling at how neat it will be, although it will be, but to put into context the implications for all the policy issues we're trying to solve right now that we know are going to matter for the rest of our lifetimes.
Hello everyone, I'm Barbara Humpton, CEO of Siemens USA, and thanks for listening to The Optimistic Outlook. You just heard a quote from U.S. Transportation Secretary Pete Buttigieg. I heard the Secretary share those comments at the White House in June at the launch of ARPA-I. Spelled out, that's the Advanced Research Projects Agency - Infrastructure. I say it that way because you may be familiar with ARPA-I's predecessors. These are government-led efforts to fund the development of high-reward next-generation technologies. There was DARPA, D for Defense. This was started in the Eisenhower administration and has advanced numerous breakthrough technologies in national security. Then, in 2009, came ARPA-I, E for Energy, to fund game-changing energy technologies that are typically too early for private sector investment. And in 2022, Congress funded ARPA-H to drive advancements in healthcare. Now, in ARPA-I, the federal government, working with the Department of Transportation, will catalyze American science, technology, and innovation to build the transportation and infrastructure we need for the next century of American leadership and growth. This is significant because, get this, in the race for electric autonomous transportation, we've seen tremendous R&D investments in the vehicle technology, but not so much into infrastructure. In fact, research and development investment in vehicles is 50 times larger than for the infrastructure that those vehicles depend on. What we're going to see now with ARPA-I is a push to advance technologies that bring transportation into the future, to make how we move people and goods more sustainable, safer, and efficient. So, as Secretary Buttigieg said, things start accelerating in a big way. And you're going to get a sense of those possibilities in this episode as I talk to two startup founders working on technology promising to transform both how our infrastructure is built and how it's managed. Ginger Krieg Dosier is the founder of Biomason, a company using biology to grow concrete sustainably. Angus Pacala is the CEO of Ouster. They're using an advanced sensing technology called Lidar to make our infrastructure smarter. And I'll share with you that I do serve on Ouster's advisory board. Ginger and Angus both joined me on a panel at the White House launch event for ARPA-I, and I really enjoyed this opportunity to delve deeper into the work they're doing. Take a listen. Ginger, Angus, it's great to have you both on the podcast.
Thank you, Barbara. Pleasure and honor to be here.
Thanks, Barbara. Looking forward to it.
One of the things I really want to hear about is your origin stories. I know that a big influence for me was being raised by math teachers. And I remember actually being surprised that other kids didn't do math equations for fun at home. Ginger, your dad worked at NASA, and then his weekend hobby was casting concrete. Do I have that right? Tell us how transforming concrete became a passion for you.
That's correct. My dad was always busy with home improvement projects, and casting concrete was essential. As a curious child wanting to learn more, he taught me how to mix cement, water, and gravel to make concrete. And I honestly was just fascinated by this liquid stone. And around the same time, I visited the beach for the first time. And instead of jumping into the water, I remained on the beach, just picking up shells, so curious about how they were made. And, they're strong and they're durable. So later in life as a student in architecture, knowing that we have a limited palette of construction materials that we use as architects, and it is our responsibility to choose materials that will last for decades, if not centuries, in our built environment. For me, it was important to look at, well, how were they made? And I was surprised to learn a lot about cement and concrete, and looking at cement as the core ingredient of concrete and how much carbon emissions that it releases. So essentially, to make concrete, you take cement, which is manufactured by using limestone, and you burn it at high temperatures just to get the calcium. And that CO2 just goes away. And so that just didn't make sense to me. And one night, I was up late working as an intern at an architecture firm, and I wrote down in my journal, what if you could grow cement similar to how nature is able to do it? And that was the beginning. And so from there, it really was a quest, almost a polymath quest, to figure out, okay, let's study coral, let's study seashells. How is nature able to grow cement without compromising the environment, and actually rather partnering with nature?
Wow. Okay. So an inspiration that really began when you were a child. Angus, we're going to get more into concrete and cement, but Angus, I'm actually interested to hear if you have a link as well that started in your early years.
I actually do, and I come from a long line of academics. So my grandfather was a chemist at Princeton. My dad was still is a biologist at Princeton. So I grew up in an environment that was highly academic, but they also were experimentalists. So there was a practical side in the duology of theorists and experimentalists. And I decided to take an engineer's path, I think, in life. I always realized that I was even further onto this experimental, intangible side, and decided to go and do an engineering degree as a result. Now, I chose to go to Stanford actually because in high school, I had watched a Nova special about a DARPA Grand Challenge, which was an autonomous vehicle race in the desert in 2005 and 2006 for this emerging technology called autonomous vehicles. And Stanford ended up winning that challenge. And it was a team of researchers there that really inspired me to want to apply and go and do engineering at Stanford. So, and actually in that episode, they talk about Lidar technology as a critical new technology all the way back to 2005 that was being brought to bear for giving these machines vision. So did my degree, and out of Stanford, I wanted to do something important. I hadn't really gotten to sink my teeth into big problems at Stanford. Learned a lot, great experience, but you're still learning. And Lidar was this chance to dive in, start my own company, and do something that I felt was important and could impact kind of safety and efficiency and quality of life across many different industries. So here we are, and another decade later, and I've been working in the Lidar industry for almost my entire career.
It's inspiring to think about these sparks, the things that capture your imagination that then turn into a life's work. And so our audience obviously wants to get deeper into both of these topics. And so, Ginger, I'm going to turn back to you. And let's hear a little bit more about the journey of starting Biomason and the work you're doing today to achieve that goal of reducing the concrete industry's carbon footprint. I see two distinct areas where you've clearly made a lot of progress. First, you're making the process of creating concrete more sustainable. And then there's this idea that we can actually make concrete smart. Let's start with sustainability. How much has the team at Biomason grown in the last 11 years, and what have you been able to accomplish in transforming that manufacturing process?
Both of us founders are architects. So in architecture, you're not taught all the different chemistry and biology. And for us, we wanted to get into the material and explore and play. So where did this mean it would go? Developing a technology that has to be easy to use. It needs essentially for the technology to be packaged with all the intelligence so that you don't have to have a degree in biology or chemistry to understand what's really working, but be able to have a product that can go into existing infrastructure. And that was really important for us because new materials, they take a long time to get out into the world, and also looking at the global supply chains, looking at all the different elements of infrastructure that's required. That became very, very important for us, is how can you make this as easy as possible to use? So today we have our headquarters in Research Triangle Park in North Carolina. I was teaching architecture here over a decade ago and started to find a great community to collaborate with. So different researchers, different disciplines. And what's so exciting was starting to get the initial non-dilutive funding into the company through various government groups for being able to explore, what's actually possible. But what was important too was just starting a transdisciplinary organization. So being able to attract, over 60 disciplines to come together to solve this big challenge. I mean, cement is the world's most man-made product. It accounts for 8% of CO2 emissions. So it is a very large problem that we need to solve. And I'm excited because now is the time for the company going into commercialization. So that means being able to manufacture not just in North Carolina, but in other areas around the globe.
Oh, this is exciting. And I know we're going to be talking to Angus a little bit about scale too, but first I just want to pause a minute and think about that second objective of making concrete smart enough to do things like actually absorb pollution. After you spoke at the White House, I believe we heard the Deputy Assistant Secretary for Research and Technology at the U.S. Department of Transportation, Robert Hampshire. He said he had never heard the terms genetic engineering and transportation used together in a sentence. And I also recall you saying that concrete could learn how to be self-healing too. Tell us how in the world that happens. What are the possibilities here?
Well, for us, because it's a biological process, you're literally growing the concrete. It becomes harder throughout the production process. So that means that you have living systems that are working inside. We discovered that there were self-healing features one day when we were producing an order that was needing to go out the door in about a week. And one of the small units that we were making, it dropped onto the floor and it broke in half. And so we simply just put it back into the production process and it grew back together. So we're like, that's curious. And we started looking at it deeper. When you think about what's happening from a scientific perspective in growing, we use microorganisms which have the ability to produce a structural biocement. And they do that in the presence of calcium and carbon ions that are coming together. So being able to, have a material that has what it needs in its surrounding environment to help it continue to grow became of interest for areas like the marine environment. So imagine how many issues that we are starting to have with our marine environments, our shore restoration or shore defense. And products like a conventional Portland-based concrete really aren't very compatible with marine environments. It's a high pH material, meaning that other organisms that are in the environment don't necessarily like to attach themselves to that. It also doesn't have a good lifespan, meaning that concrete underwater, once you start getting infiltration of seawater and salt, things start to crack and you start to get failure. And then the process of going in and repairing it is challenging because you have to go underwater, you have to find different materials to patch it, and then you get bimaterial and discompatibility happening. So we were excited about, let's see if we can grow it underwater and then put it under some stress, crack it, and watch it grow back together. And we've done several experiments with that, with funding from the government for that. So it's exciting because it means that being able to put intelligence into, such a material like a cement or concrete that's underwater and imagining what it can do in the future. So for us, when we received the funding from DARPA, it needed to be able to continue to grow in perpetuity. So that means it did not have an end point in sight, but rather it began to become a part of the ecosystem. And that means that other creatures and other plants that are in the marine environment started to attach, and then they created their own ecosystem. And that's really about the compatibility that we're after in terms of what the material of our future needs to be, that we can coexist and that materials can become smart and do things like grow or self-heal, but then also absorb pollution, which is very, very important for where we're going in our future.
Well, this is exciting. I mean, the work is being done right now to discover the art of the possible. And actually ARPA-I will be a fabulous proving ground. We'll come back and talk about that some more. But I want to turn to Angus because as you've pointed out, the Lidar technology is one that's been around a bit longer. And now it's a matter of unleashing it. Ginger's focused on a substance that's only outranked by water in terms of consumption. And Ginger's working to make that more sustainable. Here you are, Angus, working in Lidar, that the real issue is to scale its use and make it affordable. So we'll need to get into all that. But first, would you, for our audience who may not be familiar with the technology, tell us what Lidar is, and then tell us about the work that you have ahead of you to make it commercially viable.
Yeah, and I think everyone knows what concrete is, but half the battle with Lidar is just educating about what is possible, what is Lidar, and where is it going. So Lidar stands for light detection and ranging, and it's similar to sonar and radar and actual echolocation, which is used by bats. And the fundamental principle is that you emit some sound or radio wave or light waves, bounce it off an object, and time how long it takes to come back to your ears or your sensor. And you can estimate the distance to that object. And so Lidar does that with laser light. And Lidar is really the forefront of this detection and ranging technology. And it is giving eyes to machines. That is the fundamental goal of Lidar technology, is to give eyes to machines for the very first time. And there are a lot of reasons why that's important. But just to think about every animal that you're aware of can do amazing things. And it can do those things partially because of motor control and its muscles, but actually equally because it can sense its environment and it knows what's around it. Machines are really held back by their inability to sense their environment. They can move. You can have a remote control car, but to make that car drive itself, to make that car intelligent enough to prevent an accident, requires that you give it vision or eyesight. And Lidar is the best sensor for doing that. It's even better than cameras, and this is why we need to commercialize it. There are other sensors that are available, radar, cameras, but Lidar is dependable in all kinds of weather conditions. Whether it's light, whether it's dark out, whether it's pitch dark, Lidar produces its own laser light, so you don't need to have headlights on or a street light in your environment. And it can pierce through snow and fog and rain to see the environment that really matters. And so that resilience allows you to start building safety critical applications that rely on Lidar as the sole kind of input. And this is where it gets important. Like, why are we commercializing this technology? And the first place is really automotive. Car accidents are this horrible problem in this country and actually in the entire world. There's 40,000 people that die on US roadways each and every year. The trend is going in the wrong direction. And globally, there's over 1 million people that are hurt and killed on roadways. Cars need to be safer fundamentally, and to be safer, they need to know what to do to prevent an accident, which means giving them the eyesight to do that. So Lidar is a big deal for being put into cars, but it's also interesting. It can be given to fixed objects. Fixed infrastructure can be intelligent, like your traffic lights and other systems that are relevant to transportation. And so my goal is to get Lidar affordable enough and capable enough that it can go in the car, it can go in the traffic light, it can go into the airport, taxiway, and all of these places where currently we have kind of simple systems to control and actuate and make them highly intelligent and thereby much, much safer.
Yeah, it's interesting. So you started Ouster in 2015, and you've mentioned the ability to give machines eyes. I know you're working on robotics and industrial applications. And in transportation, this question, I remember going to the Consumer Electronics Show and seeing smart cars. It was obvious the car needed to have the sensing system so it could know what to do in a situation. But then also seeing the same technologies, as you say, being used in the infrastructure. And we know that there's been far less investment in the infrastructure itself. You're focused on both now. What do you think is going to be the leader here? Is the automotive industry moving faster, or is the smart infrastructure industry moving faster?
It's interesting. You hear so much about automotive, and there's immense potential for the technology there, but there are also a lot of gating kind of issues with getting this technology out. There's a very high bar for rolling out a car that can drive itself, and we can see there are nightmare scenarios if you get that wrong. And you can think about it kind of like rolling out a plane. If you're developing a plane, you need to be absolutely sure that if that something doesn't go wrong, and if it does, that the system is resilient, because the repercussions are quite catastrophic. That's also true of an autonomous vehicle. There's going to be very little appetite for autonomous vehicles to have issues. Traffic infrastructure, believe it or not, is a little more of a solvable problem because you can always revert to a simpler system. And so I really believe in the ability to roll out more intelligent, more capable versions of our traffic infrastructure. So what I'm talking about is literally putting LiDAR sensors onto traffic lights, into wrong way signal detection and things like that, making them more capable, much safer, and reducing congestion. But they also, if something goes wrong, they can fall back to the system that has existed for the last couple decades, right? Or in many cases. So that elegant fallback is really important because it allows the technology, in my opinion, to be deployed much faster. And really what it's taken is awareness and readiness from the technology to actually start talking about transportation infrastructure as a major new market for LiDAR. So I'm really excited about it. And I think the ARPA-I event and things like that are a good indication of where this is going.
Yeah, and right now we're having a lot of conversation about artificial intelligence. By the way, at Siemens, I like to talk to my colleagues about augmented intelligence because AI really is here. It's a tool that we can use to help expand what's humanly possible. Here we've heard Ginger talking about smart cement. You used the term at the White House, ambient intelligence. Tell us what you mean by that and about how that links into this discussion of smart infrastructure.
Yeah, so ambient intelligence for me is this, kind of my goal ultimately, and with a lot of technologies, concrete would be an example, is to put immense technology and capability into something that you interact with every day, but really have no idea that technology exists, right? You may not know that you're walking past a concrete highway that's been built with this fantastic new technology. And my goal is for you not really to be aware of why your traffic light seems so much better at anticipating your desire to turn right or turn left or be a pedestrian at the crosswalk. And so that I think of as an ambient version of intelligence. It's not in your face technology. It's providing real benefit to you. But the point is not the technology. And so the ambience of, getting this technology everywhere and making it a mundane part of everyday life is a real a motivating factor for me.
It's just there. Yeah, that's great. Hey, listen, Angus, I want to stay with you for one more question. And this is about something I've heard you voice. The Ouster is really energized by a topic of Moore's Law. And I know the fellow optimists who are listening to this podcast will want to hear your view about the potential to bring Moore's Law to infrastructure. Now, this comes from Intel's co-founder, Gordon Moore, who very accurately predicted back in 1965 that the power of computers and software would increase at an exponential rate. How does the technology you're working on with the LiDAR now help us understand the potential to dramatically improve transportation over the next decade?
Yeah, there are two ways. So the first is the quite literal, like putting more computing power into the legacy systems that exist. We could just attach a more sophisticated processing unit to existing infrastructure, like a traffic controller, and feed it more data, and it will be a better system, right? So that digital technology is literally driven by Moore's Law, and so that those products year over year, if you put new computer chips in them, could get better. But I actually like to think about Moore's Law as more of an idea of iterative development and improvement, because I think that's the more important thing that is being brought now into some of these other verticals is the ability to iteratively improve a piece of fixed deployed infrastructure after it's already been deployed. So instead of having to wait for the redesign cycle or for the 15-year life cycle of a piece of equipment to wear out before you replace it, being able to update it really with software is what I'm talking about to improve its capability over time. A great example of this is the Tesla autopilot system, which it just shows you could build software updatability into safety critical systems and improve those vehicles over time. Now, there's a right and a wrong way to do it. You have to be very careful about updating those systems. But the idea, it's taking the same idea of exponential rate of improvement that was made possible by chip design and digital technology from Intel originally in the semiconductor industry, and applying that type of exponential iterative development to new connected infrastructure. And that's what I think is exciting, is that you're not locked into the capability that you deploy day one in your systems.
We won't be talking about fixed infrastructure. We'll be talking about upgradable infrastructure. I love the concept. Actually, this is a really good point to shift the conversation to this larger perspective on what it takes to bring groundbreaking technologies to scale and the collaboration that's required. The thing is, these days, no one company can do everything that's required. And I think that's the power that we see in the ARPA-I model. The idea that the federal government is committing to investing in some high reward technologies that can transform transportation and to strengthen the ecosystems needed to bring these technologies to scale. Ginger, did I hear you use the word transdisciplinary? and how do you see this at work? What excites you the most about how ARPA-I is going to be working?
I think the most exciting piece is that it brings such a focused attention and increased awareness. There's so much that's possible when we look at, starting to capture data from something like cement or concrete, which we technically wouldn't even really think about. And what does that mean as we coexist and we grow with that? It also provides an actionable plan. And here's what we need to do now. I firmly believe that time is one of our biggest challenges, and we just simply don't have 20 more years to talk about it. It's about doing what we can now. Right. And I think the challenge is that large infrastructure projects take time to plan, years in advance, and we have to find ways of speeding this up, consolidate decision making, and collaborate more. Because the faster that we can start implementing these types of technologies, they can start building on their ecosystems that are around it and imagining where we can go within those ecosystems as we continue to build out. And lastly, the U.S. government is the largest consumer of concrete in the U.S. I mean, concrete it's used everywhere. I'm sure that it's near us as we speak. And it's important that there's that awareness of what it is that we're working on with the decarbonization, but then also adding intelligence, to something like that we wouldn't consider adding intelligence to, such as concrete.
Yeah, that makes a lot of sense. And here is ARPA-I in a position to actually work at that leading edge where perhaps no private sector company alone would be taking that leap. And Angus, coming back then to your concept about Moore's Law, you're bringing this into a sector that when it comes to digital technologies has really undergone much more of an evolution than a revolution. Do you think ARPA-I can help accelerate the rate of change?
I do, and I'm going to use another computer analogy here, given that we're talking about Moore's Law. But in computing software, there's this concept of a garbage collector. And a garbage collector is this little routine that is running in the background and deleting things after you're done using them in your program, and freeing up space to do something new, or consolidating what was already there that's built up over layer and layer of, over time in your software program, and making it more efficient. And I think as running Ouster, I think about the same thing with business processes. Every once in a while, you have to go and say, have we added too many rules? And can we refine these 10 rules into one? And so the same thing, I think, happens in regulation, and in legacy industries. We might have a set of rules, 100 rules that were added over the last century, where maybe 10 will do, or where we need to create a new path for new innovations to be brought to bear, because there's too much of the legacy approaches that are standing in the way. And so I don't know if that analogy made perfect sense, but that's where I see ARPA-I coming in. It's kind of piercing through these, a century of kind of ways of doing things, processes, and legislation, regulation, and doing it responsibly, but giving an option to try something new with maybe 10 rules instead of the 100 that used to exist. So I think that we're going to benefit immensely from programs like this.
I don't think I'll be using the term garbage collector when I talk to our policymakers. However, I think the concept really applies, and I do think we're dealing with both legislators and policymakers right now who are really motivated to question everything and who are willing to take a good hard look and say, what do we have to do now? So it's an exciting time to be here, and wasn't it a thrill to be invited into the room of the influencers who are actually making the change that's happening today? I'm dying to know what you enjoyed most about your visit to the White House, Ginger, when you were invited in, and then when you had that experience that day. What are the things that stick with you?
That there really is action taking place, and there's a genuine enthusiasm. I mean, this is a big opportunity that we have. It's part of the next industrial revolution that we have. So I felt that the room was teeming and brimming with the amount of excitement and what the possibilities could be, but that there was actual action behind it and funding behind it. So it was day one, of this next revolution that's coming.
That's so cool. Angus, did you have any pinch me moments coming out of the White House event?
I would second what Ginger said. There was a general sense of, we can't screw this up. This is a chance that doesn't come around every decade to really revitalize our nation's infrastructure and take a fresh look. So I love that atmosphere, and it was infectious.
That's awesome. I love to ask the question of all my guests: if we're able to successfully bring forward the technology you're working on, if we're able to scale it in transportation, give us a picture of how this will positively impact our future. Ginger, I'll start with you.
Such an exciting question. So I think that in our future, it should be a given that our manufacturing processes are compatible with the planet, and it's commonplace. After that, the excitement of the coexistence with intelligent infrastructure, being able to look at what else can be added or embedded to something like cement or concrete that actually has an impact on technologies like with Ouster and Lidar. That there's intelligence in our built environment, that our buildings talk to us, and that our bridges and roadways talk to us, and they give us real-time data on how they're doing and performing, and that there's decentralization in terms of manufacturing that can go in and repair. Those are the exciting things to me about what this future of becoming much more efficient and effective looks like.
You're helping us build it. Angus, over to you. Tell us what our future looks like.
Well, I think there's a clear goal for a lot of people working in safety critical LiDAR systems, things like that, especially in automotive and transportation, and that's zero roadway deaths. This idea of Vision Zero, really, it's real, it's attainable, and you only have to look as far as the airline industry to realize that this actually is something that you can solve with technology. Airlines didn't used to have a perfect safety record in a given year. The U.S. airline industry is incredibly safe now, and it's because technology was brought to bear and processes were brought to bear to solve the issue. And so I think this is a tractable problem in the ground transportation network of our country and our world. And I think that that's as good a goal as any, is that Vision Zero goal. And I think we're actually making tangible progress on that path towards achieving it.
A safer, more sustainable future. Thank you both for joining us on the Optimistic Outlook.
Thanks so much, Barbara.
Thanks so much, Barbara. This was a great conversation.
What I tell my team at Siemens is that the best ideas often start with a couple people and a drawing on a napkin. The power of a company is the ability to take those ideas and bring them to world-changing scale. But when we can expand our horizon, when we embrace open innovation and forge new partnerships, working together across different sectors, across different disciplines, we can accomplish so much more than we ever could alone. When we fully leverage this American innovation ecosystem, no matter how big we dream, it becomes almost impossible to dream big enough. In 2015, I had a chance to meet some innovators in Siemens who were working on a motor for electric propulsion for aviation. They had built a timeline that looked out through 2050. The concept started with a two-seater and a small motor, and it evolved to achieving regional aviation. Well, they started using advanced engineering and simulation tools and using generative AI to create a more powerful, lightweight engine, and year by year, they started seeing 2 years' worth of advancement against the original plan that they had put in place. Think about that as we discussed in this episode, enabling Moore's Law in infrastructure. Electric aviation now has the potential to change a lot about how we move. And we're also going to have to innovate how we bring power to airports, which is something we're working on right now at Siemens. Developing the electrical and digital infrastructure, what are called vertiports, for air taxis and drones. Think about aviation hubs in cities that enable vertical takeoff and landing, supported by microgrids and energy storage to make charging solutions sustainable. Imagine American transportation not only looking more like we've seen in our favorite sci-fi movie, but the new markets, the new businesses, and the new careers that emerge along with it. Thanks for listening, and head over now to our show notes to learn more about everything we've discussed in this episode. Please follow us on social media and on your favorite podcasting platform. Thank you for tuning in.